Okay, getting started up again, and I need to log in to Skype. So 1 second. I'm not completely set up yet. And yes, there's gnarly feedback. But there we go. So to recap on yesterday's events, let me pull up Emacs. Basically on the iPhone, we've got the basic input-output sounds working. And what I mean by that is we've tested, we now can, when we speak into the microphone, there will be a growing object that keeps growing until we stop speaking, and this gets saved and bounces around, and each time it bounces it makes a sound. And now we're trying to implement the effects class, and that opened up a whole can of worms. So let me pop over to the to-do list. Basically we're creating this, I gotta mute this mic, we're creating this effects class here, and well, you can see there's a lot of stuff we need to create. We've created these superclass and subclasses, and we're starting off using a dummy effect, and we're going to use collision detection at some point to transfer the sounds from the original voice entity object to the receiving effect entity, and that's going to be fairly straightforward once we have this class going. What we're trying to do now is we're about right here. We're about to define the output, which is going to require some new sound classes that take into account the real-time growing nature of these input buffers. But as a first step, well, we are going to just play back the sound, and we want to what does that mean? Create the sound and play it back. Yeah, so it looks like the first thing we will need is a sound, and we also have to populate this is output sound. Okay, so I think yeah. So this to-do list fits very nicely in this little window, and I don't know if I made it clear, but I'm working in 720p right now. This mod is actually 1080, so it goes down quite a bit. I could have maybe about 9 windows this size if I chose to use the full screen. But I have other stuff on the rest of the screen, and I think it's too hard to see in YouTube, and it's not much harder. I don't really need more than 3 windows, I think. So, well, 3 or 4 windows. So let me decide what to do next. Create the sound and play it back. Well, last thing we're working on is this buffer, pushing buffers into a vector. So this grows, and there's nothing that shrinks yet because we're not giving any output. Yeah. Let's take a closer look at what's really going on. There's one thing I am worrying about here, and our buffer for nothing effect is very different from the buffer for what is that called? Very different from the is it filter sound? No, from the voice entity object, where we have reference counting going on. And I'm kind of inclined to add a structure that takes care of the reference counting here. I think that would be good because we want to share these references, we want to share these buffers with a different object at some point, and still be able to retain it in the effect entity. For example, we might make the functionality, once you say something, you don't have to say it 10 times, but instead you can speak it into the microphone, and the effect object will capture that, and there will be some animation. From then on, every time you tap it, it makes the affected sound. Sorry, is it the affected sound? Yeah. Anyway, English. And we want to be able to have the actual sound objects will need the access to these buffers unless we make a copy, but that's really wasteful. And we want to conserve memory where possible, where it doesn't really make a difference. And the cost of reference counting is much better than cloning entire buffers. So let's make a new structure. We do have we do have the ability to use the old input buffer class. But I don't like that because these have all these Apple, it has this ugly Apple struct that I don't like at all. So I'm going to make our own struct. And in the future, we might just replace the input buffer with this struct. And I don't think I want to put it in effect entity because this is yeah, this is a little tricky. This is a slightly tricky problem. But what I'm going to say is we should put it in filter audio IO. Filter audio mixer might be okay too. Yeah. So filter audio IO or filter mixer. Well, the advantage of filter audio IO is that it is the central point that touches the hardware. And filter audio mixer, yeah, it doesn't do too much, but there is this handy update call which deletes stuff. If we use reference counting, we will need one central place to delete the objects. Yeah, and it might be a good place to do that here. So let me do that. We're going to make a struct here called, how about filter buffer? That's slightly ambiguous, but at the same time, I don't really mind because it is a buffer that will be used with filters at some point. Yeah. So, for example, oh, did you say something, Dad? Okay, I'll talk to myself. Well, basically, we need and we do need a void star, and we're gonna keep that ambiguous for now. We'll leave it a void star, and the contents will just be buffer. The name will just be buffer, because we might have other formats to deal with. What we also want is we'll just have an int for channels and an int for buffer size, num frames. Let's keep the C conventions going. Yeah, I think we're eating chili for dinner. Or we could go to Zippy's and eat. I've been talking about food in these casts, and generally what I eat for dinner becomes a little subject. Zippy's chili is a pretty unique item for Hawaii, and it's pretty good. It's hard to beat. Anyway, so we now have this structure for allocating buffers. We have channels and num frames, but the main thing is this ref count. Ref count, yeah. We could use the Objective-C style count, but I don't really like that because of the object dispatch. The message dispatch system is pretty slow. At some point, we may need to add a mixer, a mutex here. Because, and we only need to do this if we're using an unthread safe method, and that can happen a lot when we're talking about analyzing audio. The iPhone now has 2 cores, so that means you can process, well, a bunch of things at once. And that happens, there are already threads doing stuff, but they're probably not running 100% all the time. And that's kind of the goal when you're writing a CPU intensive piece of code. Okay, so now we have this buffer. So all we have to do is, we did one malloc here, but we're gonna have to do another one, and we'll call that filter buffer. Filter buffer. Yeah, what's very ambiguous about this is the audio buffer. The actual audio buffer is also called buffer. So maybe something like buffer segment or something might be a better name. Even audio buffer. No, I'm okay with this. And it's because I'm pretty used to seeing buffers, the actual audio buffer just written as buffer. And the surrounding entity, I mean, this has a real title, a real type. Okay. So what we were doing before is just doing one malloc like this. And what we can do instead is request from the filter audio mixer. Yeah, request from filter audio mixer to give us a filter buffer that's already set up. And on the other hand, I don't like that this is an Objective-C class. Okay, so this is what we'll do. Let's just move it to our C++ class. And I think there's already a lot of stuff in there, so it's not a big deal.